Okay, this is lesson 6.6, triangles and trigonometry. Trigonometry means triangle measurements. And it's used to calculate lengths of sides and measures of angles. And from this point forward, this whole unit, the whole rest of the unit is going to deal with right angle triangles only. So when you're dealing with a right angle triangle, there are three words that we need to become familiarized with. And they correspond to the three sides of a triangle. There's the hypotenuse side, and a box the letter H for hypotenuse, the adjacent side, A, and the opposite side, O. H-A-O. The hypotenuse side is always across from the right angle. It's the longest side. The adjacent side is next to the angle. Which means it touches. And the opposite side is across from the angle. Doesn't touch. So what am I talking about? What angle am I referring to? Well, in every triangle, when you're solving for a side or angle, there'll always be some sort of angle that you're referencing from. So, for example, in this triangle, x, y, z, we're going to find the hypotenuse, the adjacent, and the opposite for angle x. Now, you can label a triangle from any angle except for the right angle. So we could label from X or Z. In fact, the second example we're going to do down here, we're going to relabel the triangle, but we're going to label it from Z. So let's start by labeling from X. So we're going to label the hypotenuse with an H, the adjacent with an A, and the opposite with an O. So since we're labeling from X, we're going to put a little mark here to say from X. And we're going to start with the hypotenuse. Hypotenuse is the side across from the 90, the longest side. So our 90 is right here. The longest side will be the side that's not touching this 90. This side and this side are both touching the 90, so this side is the hypotenuse. And this would be called side Y, because Y is the side across from angle Y. The adjacent side is the side next to the angle, so it's going to touch it. The angle we're talking about is X. There's two sides that touch this angle, this side and this side. Well, we already labeled this side as the hypotenuse, so this side must be the A, the adjacent. And this A side is across from Z, so this is side Z. Finally, that leaves the opposite. The opposite side won't touch the angle we're talking about. Well, if we're talking about X, this side does not touch X. So this side is our opposite, and this is side X. There we go. Hypotenuse, adjacent, and opposite. Also, we kind of threw in there labeling sides. Sides are labeled across from their angles. So if X is here, this is side X. If Y is here, this is side Y. And if Z is here, this is side Z. The capital letters are reserved for angles. So angle X, angle Y, angle Z. And the lowercase letters, X, Y, and Z, are used for side lengths. All right, so let's try to label the triangle from Z. So this is angle Z. This is X, this is Z, and and this is y. Same as in the last triangle, because it's the exact same triangle, so it has the exact same side lengths. We're going to label the hypotenuse. Excuse me. The adjacent and the opposite. Now remember, the hypotenuse is across from the 90. The 90 is here, so this is our hypotenuse. This doesn't change between the last two triangles, or the last triangle. It's always the long side. Adjacent is the one next to the angle. Now we're talking about z. So the adjacent is side x, which leaves the opposite for side z because it's across from angle z. And there we go. The only thing that switched was A and O. A and O are corresponding to what angle we're talking about. Hypotenuse is always the longest side. So let's go down here. Here's three triangles. We're going to label it with H, O, and A from the marked angle. So our marked angle is R. So let's start with H. That would be across from the 90. O would be across from the angle. And A would be the side touching the angle. So if now you want to pause the video and try the next two on your own, I would do that. Otherwise, I'm just going to continue on and show you how to label the last two. This one we're labeling from L. Across from the 90 would be H. Across from L would be opposite, which leaves this side as the adjacent, and this side is the one touching the angle, so we're good. If we want to label from F, let's do it with H first. H is across from the 90. A is the side touching the angle. Well, we've got two sides touching the angle, but this side's already H, so this side is A, which leaves O across from the angle. And there we go, H, A, and O. So it's important that we be able to label a triangle because all the rest of the trigonometry work that we're going to do going forward is going to involve the H, A, and O sides. Let's flip it over and talk about three important ratios. So there's three very important ratios in right-angle triangle trigonometry, and that's the opposite over the hypotenuse, the adjacent over the hypotenuse, and the opposite over the adjacent. Now, why are these important? Well, these are important because when we do solving for sides and angles, we need to use these ratios. There's a really easy way to remember these, and you'll get to see that in the next lesson. But for now, we're just going to label sides, and we're going to write the ratios. So here we have a triangle with 2, 4, and 5, and we're going to label from angle F. So from angle F, the opposite side would be the 2 meters. The hypotenuse would be across from the 90. That leaves 4 as our adjacent side. So in A, we want to write the ratio opposite over hypotenuse. So we want to write the opposite over the hypotenuse. And if we do that, opposite is our O side and hypotenuse is our H side. Now we just have to go look at the numbers next to O and H. O is 2, H is 5. We have 2 over 5. And 2 over 5, if we divide, we get 0.4. Let's try our second ratio. Our second ratio is the adjacent over hypotenuse. And that would be the A over H. And A is 4, H is 5, so we got 4 over 5, which is 0.8. And our last ratio is O over A, opposite over adjacent. Opposite side is 2, the adjacent side is 4, so we got 2 over 4, which is 0.5. All right, so those are the three ratios. Now we can write all three ratios if we know all three sides. If we know all three sides, we're pretty lucky. When we work in right angle triangle trigonometry, we don't always know all three sides, so we might not be able to write all the ratios. In fact, if we only know two sides, we can only ever write one of the ratios. So let's take a look at three examples. We've got A, B, and C. Let's label our triangles with O, A, and H and see which ratio we can write. So our marked angle is C, so O would be here. H is across from the 90, and A would be the leftover side. So now we only know two of the sides. We know the hypotenuse and the opposite. So one of our three ratios has hypotenuse and opposite in it. So let's look at our three ratios. Our first one's got opposite and hypotenuse. That's the one we want. O over H. So the ratio we can write is the O over H ratio, which would be 4 over 6, which if we put that in a calculator is 0.6 repeating. Let's try B. The marked angle in B is L. Across from L would be O. Across from the 90 would be H. And that leaves A as our other side. So the sides we know are O and A. One of our ratios has O and A in it, and fortunately it's this one that's showing right here, opposite over adjacent. So we can do the O over A ratio, which is 9 over 8, which if we punch that in a calculator is 1.125. All right, there's one more left. You can pause the video and give it a shot on your own, or we can work through it together right now. Our marked angle is X. So for labeling, across from X takes us all the way over here. 3.2 is our O. Across from the 90 is H. And that leaves A as our last side. So the sides we know are O and H. And that's actually the first ratio we did, O over H. O is 3.2. H is 11.5. And if we divide, we get 0.278. And I know it doesn't look like we're really doing anything yet, and it's because we're not. What we're doing is we're kind of building to eventually being able to solve for sides and angles and triangles. But these ratios become really important. The three ratios, the O over H ratio, the O over A ratio, and the one that we didn't do in the last three examples, the A over H ratios. And if we start the next lesson, I'm going to show you why these ratios are so important, and then we're going to start solving for some side lengths. That's it for lesson 6.6. Thanks for watching, and I'll see you in 6.7.